I just closed the game.
Alrighty, we should be good to go for now. Feel free to start whenever you're ready.
Okay. All right, so hello guys and welcome to my Node.js workshop. I want to start this off with an overview of what are applications you can do with Node.js. And Node.js is best for developing real-time or close to real-time applications, networking applications. So on the left side, we have all kinds of websites, starting from the websites themselves. That would have a visual display like front ends, web APIs that are mostly backends, and microservices that are backends like specialized simple small tasks. In the middle, all sorts of live things like live chats, online gaming, notification system is also very good for developing with Node.js. Console tools is an option because Node.js has an access to the whole file system of the underlying machine and streaming of video, audio, and even files. And specifically to front-end developers, Node.js is very good for creating mock services for mocking your APIs that you need for development. So you can develop locally without doing external network calls. One moment. Okay, and so because Node.js is a single-threaded runtime, so doing CPU-intensive tasks usually will block the whole application because it's only one thread and will slow down everything else. So there are some types of applications that are not good, like not best with Node.js, like cryptography, zipping and unzipping large files, image and video manipulation. This means resizing or encoding and so on. And overall, any blocking actions, any thread blocking actions that can happening in this application. Still, all those use cases are possible with Node because it has a native way of running child processes using other threads on the underlying machine and getting the results back to the main thread when they finish. Now I want to introduce myself. I'm a software engineer with more than 7 years of experience, and I'm currently a senior software engineer at a Canadian startup, Miro. We provide smart cleaning solutions for office buildings, and we are processing IoT data for more than 200 buildings already, and more to expand this year. Next, I want to start by introducing to the Node.js. So what exactly is Node.js? I will visit the official website. And here at the top, have the simplest explanation. It's a cross-platform JavaScript runtime environment. So it's a JavaScript that can run on your machine. Particularly is designed for running on the server machines. If we dig it a bit deeper, we have seen another good description of Node.js. It's an asynchronous, event-driven JavaScript runtime, and it's designed to build scalable network applications. And again, we already have the simplest example of HTTP server done with Node.js. So basically, we create a server and we only have to pass it one function, and this function will respond hello world to any request of this server. And we'll get to this a bit later today. The most interesting part of understanding Node.js is understanding the event loop here in the middle. So you will most likely will get to learn it in and out when you dive into Node.js, or if you're a front-end developer, you also will have to deal with this because it's a JavaScript runtime anyway. But right now, I want to touch on this briefly and we'll give a simplified overview. So say, for example, we have multiple requests coming into our single process. And the way Node actually achieves high performance values is with applying the event loop pattern. So this loop, it consists of some stages. This diagram doesn't showcase them exactly. It's a very high level overview. So our application runs inside this red box. It's the code that we actually write. When the Node.js detects that we want to do something externally, like reading the file from the system or doing some network call, this will be delegated to operating system. And since then, and the application will continue to go on. So some time will pass, the operating system will notify our application that it's done its job, like getting the file for you or reading the file rather, and will push a callback or like push a process to the callback stack for our application, and event loop will eventually pick it up. So while operating system works, reading a file or requesting some external resource, our application will still continue to run. Yeah, so in short, any heavy operation that would block the application is possible to launch externally, and there are native APIs to do that. And yeah, while this may be hard to understand at first, but I'll give you some examples today. Next, I want to talk about how we would go about installing Node.js on our machine. Again, the perfectly fine solution is just going to the home page and downloading binaries for your own operating system. Yeah, everything is supported. There are a lot of versions of everything. It's a good solution, but what I recommend doing is using an external library. It's called NVM, which is a Node version manager. And it's a very nice tool for installing the Node.js and switching versions. So you don't have to download different files and deal with installation, updating paths in your system and so on. So how it is done, you just basically install it with a script. Yeah, it's run very fast for me because I have already installed it. But then you have access to the NVM command, and you can ask it to install version 16, for example, of Node. Yeah, again, I've downloaded it before, so it's just switching versions. I can confirm it with running node-v command, and I have version 16. Whenever I need to switch back to 18, for example, I will type nvm install 18. And now I have 18 as an active Node version. And a little about versions, I recommend going with even versions because they are always long-term support and are ready for production. Odd versions will have latest features but are not considered stable. They are fine for educational or explorational purposes, I guess. Next, yes, some time for demonstration. Let's start with a file system demonstration. So first of all, we want to import a module that we'll be using. And how we do this in Node.js is we type import, and then we type hint, it's a core module of Node.js, and then the module itself, which is file system. And by the way, you can get all the documentation for every version on the official site. It's very good. Here on the left are all possible core modules for Node.js. And for example, file system specifically, going on the first link will give you the same example of importing the file system module. Next, yeah, I want to showcase how actually doing blocking and blocking file reading in Node.js works. Just yet to give you some understanding of the more deep understanding of the event loop, because it's important when you develop applications in Node.js and you want them to be performant. So on the third line here, I have a console log statement, which will output any text given to it to the console. So I want to measure when my script starts. Then I will start reading the file. I will assign a data constant. The result of reading file named data.txt. I have this file right here. It's just 3 lines. Then I want to output the data I just read to the console. So the result of this function is a buffer. So I won't convert it to string, so it's human readable. And I'm doing this here. And finally, I will just output end line to the console. Now I'll run this example. As expected, we have start at the start and at the end, and our text data file in the middle. So that's fine. But as you can imagine, this file read is a blocking operation because our script stopped while it was reading data. And in Node.js, you can also kind of get hint of what how your method would operate, because they also always include the sync if it's a sync method. And for every sync method, there is asynchronous counterpart, which is more preferable to use. Yeah, and now I want to show you the example of an asynchronous file reads node. For this, we would do mostly the same. We select the core node module of file system, and then we type dash promises that would allow us to use the asynchronous operations. Again, I have start at the start and line at the end, and I want to read the file. Now, I only read I call the read file function. You can see it doesn't have sync, so it's asynchronous by default. It's the same file, and then I have this then attachment will use this callback function. So we call in Node.js or JavaScript, you might be familiar with this or not. So anything that is queued for execution sometime later would be called a callback function. So this is our callback function. It will receive data once the file is read, and it will do the same. It will just output it to the console. Now, actually, let's run the script. Yes, and so we see that we have the start line at the start as expected, but now we have end line output second, not last. This is because once our application hit that line, it delegated this to operating system and queued this callback for execution for some time later when the operation is done, and it continued to work. So it output end, and sometime in the future it finished reading file and displayed its contents. So yeah, that's a basic introduction of how synchronous versus asynchronous file reading works, and goes for almost everything in Node.js. For every synchronous function, or in each model, you have an asynchronous counterpart. Keep in mind, reading files synchronously is not always a bad idea. For example, when you are starting your application first and you want to read configuration data, from your machine, or rather env variables, for example, it's really fine to do synchronously, because it's vital for your application to start. But once you are running and serving requests, you want to optimize for speed, so doing a synchronous action is a preference. Okay, next, I have a next example that will include network input-output. Okay, again, I will briefly, I've covered it with console logs, so we can observe how our function runs. This is another approach of running asynchronous sections. So basically, you can make any function in Node.js asynchronous if you type hinted with prefix it with an async word, and when having a async word, you can use await inside the function. So this works like magic, or it looks like magic rather. So actually, let's just run this and see how our application behaves. First, I see the before line, so it's fine. We expect this before the function run. Then I see the fetching line here, and right after it, I see an after line. So again, as you can imagine, this works with like a callback that we observed earlier with a file read. So once our application hit test method. It's a fetch is a request to external address. So in my case, it's just a placeholder API. Once it hits it's this line, all the rest of this function will be like combined in the callback and put out for later. That's why it seems like the function has exited and outputted after. So it's actually happened. And once there we got the result, and by the way, never mind this warning because fetch API is an experimental feature right now. We have our data here, and we have our console done here. So yeah, this is another way of running asynchronous operations with async await. So the best thing about this that this code looks linear to us. So we expect that we would see first the before, then fetching, then the data, then done, and then after. But yeah, the Node.js is smart enough to work it out and do this asynchronously. Another thing if I want to make this blocking, I can also put a wait here. And if I run this again, I will have the exact expected, like human expected sequence of running the commands. So I have before at the start and after at the end. And in between, I have the whole body. So this commands Node.js actually to await the result, the full result of this method to be completed before outputting this line. So this is a blocking action. But of course, at this time, like we don't need this. So we run it asynchronously. Okay, another interesting concept in Node.js, it's an event emitter. So event emitter is a like deep topic on its own, and it's a very powerful pattern for development of modern applications, and you can think of them on different levels. They can be inside one application, or like with microservices architectures where all applications communicate just with the events. And the principle is simple. You have one application acting as a publisher here, and that piece of software will emit events, and you have 0 to infinite number of subscribers that would listen to that event and do some action. And the good thing about this is nor the publisher nor the subscriber should know anything about each other. Like they may be in one code base or maybe on different continents, like integrated into different applications. It doesn't matter. So now let's go for a quick demo of events, of like core events in Node.js. Okay, so we can start this with importing event emitter class from core module of Node and events module itself. Then I want to extend this class to create my own class that I then can instantiate. I will have my first subscriber that will just output a line to the console. And the way I subscribe, I type on method, like my emitter on, and I supply an event name I want to listen for, and I supply a callback function that should be executed. So this is our subscriber, and this is our publisher. In the end here, I will emit event on my publisher with the same name I subscribe to. And if I run this, I get the result I expect. I have one event and one listener, so I have one console log line. Now I can add another subscriber to it. So I will subscribe to the same event, but now I will pass another callback function to this. And while emitting the same event once, I now have two actions computed on my listeners. Now so you can use this pattern to communicate changes in your application between different modules, or as I said, it can be used to communicate changes over network to like very external applications. Not this exactly, but the pattern is the same. You have publishers and subscribers. My second example is like a math application that will have two subscribers. One will add the supplied values, and while the second will multiply them. And I will subscribe to the compute event. So whenever our publisher emits a compute event with two numbers, I will do the math and output everything to the console. And if I run this, I have one operation and I have two results. So that's basically how publisher subscribe pattern works. We'll also observe this pattern in a bit when we will be developing a HTTP server and accepting client requests. Okay, next thing I want to go over is the basics of HTTP services in Node. So as usual, we use a core module HTTP from our Node package. Then we call create server, and all we have to do is pass it a function that will be executed on every client request. So right now I have it's very simple. I set the status code to 200, which means okay. I set the header for content type to be text, and I will process only one route. I will check if my requested URL is /by. I will respond with by. If I see anything else in the request URL or it's an index page, I will respond with hello world. This part is like a default listening configuration. I want to listen on the local host port 3000, and this is command that start listening this port and host name and start the server actually. And we can actually interact with it. I will run it. It says server running, so this is output from this callback. It's good. Now I can interact with curl. I can call localhost 3000 and I get hello world. Any other route is hello world, and if I find a type /by, the route that I defined, I will get the by response. So this is like a very basic HTTP server you can do with Node.js. But as you can imagine, it's rather difficult to build highly scalable or bigger applications using just this approach, because you have to have all your logic inside this one method. And that's why we use packages or libraries and frameworks for web development that simplify this for us. So Node.js actually has a very large open source library. This is PMJS. Yeah, and PMJS is the main package search engine for us, and version and Node has an npm command line tool, which is a Node package manager. The way we work with this is, I will start with this example I have prepared. So say we have a date, and in JavaScript we can create a date by just calling uDate function, assign it to our variable, output it. It's in UTC by default. Say we want to know what would be the day like 3 days later or 3 days after this time exactly. And the way we can do this in native JavaScript is we will get time in milliseconds from the current date. Then we add an offset. This number is 3 days in milliseconds, and create a new date from this result. And if I run this example, by the way, we run our Node applications by typing Node and the script name. I can see that the results seem correct. It's 3 days, but as you can imagine, like 3 months from now, and if you don't have the comments, and you shouldn't, most of the time you shouldn't have comments in the code, because if you have to comment your code, it's probably not very well written. In 3 months, you would have hard time understanding what this number means. You have to calculate it. If the variable names are not talking for themselves also. So we have libraries for data manipulation. I want to showcase one of them. It's datefns. And it allows all sorts of data manipulation, including time zones, internalization, what else? Duration, comparison, time ranges, formatting. Yeah, there is a lot of things. So doing this in native JavaScript would require a lot of effort from you. So how we work with modules, we first install them, and we can do this by typing npm install, or we can just type npm I and the module name. After that, we can start using this in our code actually. So I will import the addDays function from datefns library, and now I will create another variable or a constant here for 3 days later date. And all I have to do is call this function that was written by open source community. I will pass it my current date and the amount of days I want to add. And I expect results to be the same. And yeah, here they are. But as you can imagine, this line is much easier to understand. This is this line. And going further to my next example, I have a time zone example here. So for this, we want a datefns tz package. I will install this again by typing npm I datefns tz. And then I would use the format time zone function from this package. Say, for example, you want to convert this date to the New York time, Paris time, and do this like once. If you do it with native JavaScript, you have to first research what are the hourly offsets for each time zone, then apply them. And by the way, you also should consider winter time savings. So, but with the libraries, it's all pretty easy. You just use one command and it takes care for the rest for you. And I type Node.js, and I have my date now in two formats output. So libraries really help us build software faster, and it gives quality because this software is tested by the community. It has test coverage. It has if there are issues, they are reported and solved and so on. So it's really cool. Okay, next, I want to show you is how we actually build APIs. And I want to compare, first I want to show you how I would build a native web server API, so using just the native HTTP model. And then I want to introduce you to the Fastify library, which is a framework, or I call it rather a library for web development. And yeah, so let's start. I will have an API that will have two routes. One would just to get all the users I will have my users in the mock database. And one is to register a new user with the post request. And for anything else, I want my API to respond with not found. Okay, let's see how. Oh yeah, first I want to showcase the users, my mock users database. So it's in memory construction. And yeah, that's why Node.js is good for, because it keeps the data in memory. You can actually, once this application started, you can populate this array or modify it, whatever you like, and it will be kept in memory until your start application. So it's very good for demos, mocking, and so on. So my users mock database will have two methods, like all, that will return all the data that I have currently in the memory for my users. The second method would be register, and I will check if my user already exists by comparing emails. This is the function. And if this is the case, I will throw an error that my user already exists. If all good, I will just create a new user and push it to the end of my array, my memory array. So it's rather simple. What I want to focus is on the HTTP server itself. So yeah, again, we import, or rather require, that there are also different constructs for importing and require, depending on what is your running scenario currently. But this time I will require Node.http module. Again, we see the create server function that will have this callback passed to it. And this is my application API logic. So first of all, again, I will start by setting 200 code by default, and I want to return JSON as a response by default. Then the interesting part starts. Whenever I see that the requested method is post and the requested URL is user register, I will start reading the client data. So the request object here is actually an event, an event emitter object, which I showcased earlier. And here we have an on to subscribes to this object. So to read the data with native HTTP library, we have to first create an empty body text. So I call it body, you can call it whatever. And we subscribe to the on event, on data event. So whenever we read a chunk of data from the client, for example, if it's a very large, registration form with a lot of fields, it may come with chunks, but for our case, it probably will be one small chunk. But anyway, we have to read it in that way, just listening to events. So whenever the chunk arrives, we will add this new chunk to the body. Is just a text. When the client finished uploading his request to the server, the end event will be emitted on our request object, and here we should apply our actual logic for the route. So first of all, we have to JSON parse the body to JSON because it was a text field only to create an object. Then I try to register a user by calling register on my users on my users mockdb, passing email and name. And if everything fine, I will have a new user object return, and I should end the response with this string. But this is an object, so I first have to stringify it with a special method. This is a built-in method of Node and JavaScript actually. I should pass a text, or otherwise I will get an error here. If anything goes wrong, I will catch an error here, and I will change the status code to 422. And again, I will stringify the object of error I will output to the user. So it already seems a bit complicated at this point. My other method is, my other expected API is the get route with all the users, and it's rather simple. I have to check that my method is get, the request method is get, and the URL is users. And then I will just get all the users, stringify them again, pass them to the response callback. And if I didn't hit any route, I will just response with route not defined. We can actually start this example by typing node index.js. And I have a few requests ready for testing here in my Postman. First, I will try the get to the users route. And as expected, I get two of my users that I initially had in my database. Second, I have post request to users register with email bob@test.com and correct name. I send it. I have 200 OK response, and I got my user back with the ID of 3. Let's check all the users. Yes, now we have him here. Finally, I will try the undefined route. I will do a put request to users delete, for example. And as expected, I have route not defined. So this is working fine. It's perfectly fine for demonstration or educational purposes, I guess. But as you can imagine, I want to show. So this is our logic, like our business logic that we only need to solve our task of creating API. So those two lines, and this one line. All the rest is like bootstrapping, for example, these status codes and returning, setting the content type mainly, because if you don't do this, you will probably get an error. And most of all, disturbing here is the branching of the ifs and else ifs. For example, it's already a big chunk of text with only 2 routes. If we would have 20 routes, these would become very cluttered, and you would have always, you will guess always, try to guess what is the best position to put your new route, here, or like here or here. And also the need of reading data manually from the request object and catching the end event is kind of yeah, it just takes a lot of focus from your actually solving the task. So that's why I recommend, for at least for simplest APIs, I recommend using a library, a specific library. This is a Fastify. It's a rather new library, but it's already pretty popular. The other approach, or another popular library, is Express. Yeah, I do not recommend like if you're just starting to learn this, I would also always recommend starting with Fastify because it's like more fresh. But Express also has its use cases, and a lot of projects use this. I think far more than Fastify right now. Yeah, but in Fastify is easy to showcase this example. So how we do this is we install, actually we again npm install our library by typing npm install Fastify. We import it, we instantiate like a Fastify class. And by the way, I use the same users mock database in this example. And now the interesting part begins. We just configure our routes with the helper methods. Here I have get request for the users /users route. I will receive request and reply objects, but I don't need request right now. I will just reply send all my users from database. And I don't have to do JSON stringify here because the library will do this for me. And my second route I expected to have in my API is post to users register. And again, here we already have access to the whole fully read body object, and we just can extract email name from here and execute our business logic. So we try to register a user. If everything good, we just send a reply with the user object. We are not converting anything here to string. Again, if anything goes wrong, we reply with 422 and with the error message. And the global not found handler, we can set it's also documented thing for the library. We will just reply not found with everything else for everything else. And this is similar to the core module HTTP listener. This will just listen to the port and yeah, log any errors if they happen and the exit process. So yeah, I can start this example exactly the same. I will launch Node.js. Oops. Yeah, I think I need to install my dependencies. Yep, it's now running. It's not logging anything. By the way, we can just do this. I think logger true. Yeah, and now it says that it started, and it will log everything in the console also. So this is exactly the same API. And I expect it to behave the same. So yeah, my get users route. First, after application start, I only have 2 users, so that's fine. Then I try to register a user again. It's working fine. If I do register on same email, I will get an error. Good. And if I try an undefined route, I will get a not found response. So as you can already see probably that this code is far more readable than the previous example. of a native HTTP server where you have to manually do a lot of stuff. And again, this is why we prefer to use libraries, because you want to focus on solving your problem and not doing all the grunt work around that. Okay, another interesting example, by the way, I want to show you. I think we don't have much time left now, but this is also interesting because when running projects on the Fastify or Express, rather on any library, you can build up your application and make it more complex more easily than doing just native. For example, here I have a post route for the math operation. I will expect two variables a and b, and I will return a result of adding them together. And again, let me first start the server. I have my request prepared here, so I will /math route. I will provide a and b, 1 and 2, and I will get 3. If I change anything here, I get the expected result. But say, for example, we want to protect our API from processing false requests. For example, if someone tries to pass a string or some text and not a number. And Fastify has a very nice way of request validation. So how we do it, we create a request validation object and we pass it in between our route and our function that will be called for this route as an object. And this object is a schema, a JSON schema, which is also has yeah, it's a popular schema which is like used in a lot of projects and for example in the OpenAPI documentation and so on, and also in validation. So we define our body that we want it to be of type object, and we want it to have two properties, a and b, each of type number. And again, we assign this to our post route for validation. So every time the request hits our server, this will validate against this JSON schema. Oh, sorry, my postman keeps breaking for some reason. Yeah, again, so if I send numbers, I get everything fine. If I try to send text and I have validation in place, I automatically will get a bad request response. And I will have a hint here. Oops, sorry. I will have a hint here that a must be a number. So if I provide two inputs incorrectly, oh, I see. It still says a must be a number, but this is configurable. You can check them all at once and provide the details for all the errors, or you just fail fast and provide the details on the first error that you meet. So yeah, this is mostly it. I want to talk briefly about, about the roadmap for Node.js if you want to start learning this and dig deeper. So here on the left, I put out some basics I think that are good to have for everyone. So Bash scripting or console tools is like essential for every developer, I guess. Git is a version control system. It is also essential. HTML, SSS, CSS is how our web pages look, so it's good to know. Like if you are backend developer, it's not required to have, but it's good to know because you don't want to be stuck trying to add a shadow, for example, to some text. It's a simple task, so it could be done by anyone. And the only way it's good to have if you are debugging something. And of course, Node.js, Node Package Manager, and the core modules of Node.js. And I put JavaScript in a separate box here because JavaScript on its own, like it's a very old language. It has its limitation and legacy that is good to know about. How event loop works is essential for understanding, for a application, how the process flow works and so on. So once you have the basic, you can start by adding some databases. MySQL and MongoDB would be a good choice for start. They are different kind of databases, being SQL and NoSQL. Express, Fastify, as I mentioned, the libraries that simplify the web development. Then you would go testing, automated testing, so you can cover your code that you write with the automated tests that will be run for you, for example, in the deployment pipelines. And this is especially useful for bigger applications that will make them more stable and extendable in future. And some deployment related stuff is Docker, is a containerization tool, and GitHub Actions to run tests actually and deployments and build your applications for production. Later on, you can introduce Redis to your stack. Redis is a powerful solution. It's most of the time it's referred as a cache subsystem, but actually it's a very powerful database on its own, similar to MongoDB. It is also a common solution for messaging systems written in Node.js and queue systems written in Node.js, like distributed queues, priority queues, and so on. Next high-level frameworks I recommend to look at is Nest.js and Next.js. And here in between you have TypeScript, so you can start to learn it sooner or later. But essentially, TypeScript is a superset of JavaScript that adds strict typing above the JavaScript. JavaScript is loosely typed, so you can have some fun stuff happening. For example, if I type 1 plus 1, I will have 2. If I type 1 as string plus 1, I will have 11. So yeah, and if I add 0.1 plus 0.2, I have a very unexpected result. So those are the things of JavaScript, and like as I said, JavaScript has its limitations and legacy stuff, and writing in TypeScript makes your application more stable, especially again on the bigger projects and on the bigger teams. If you are just starting out, JavaScript and one of those frameworks is perfectly fine. Design patterns, design patterns are good to know. Those are solutions to common software engineer problems, so you don't reinvent the wheel. And cloud, of course, learning some of the cloud platforms is good, because eventually you will deploy your application somewhere on the internet, and they offer you a lot of flexibility in that case. And yeah, finally, if you want, you can easily expand and become a full stack developer later on by adding front end to your knowledge. I recommend Reactor View. It's again, they are written in JavaScript, they support TypeScript, and it fits perfectly fine all this ecosystem. So yeah, that is all for me. Thanks for coming here today and listening to me talk.
Thank you so much for hosting. We really appreciate it. And one more thing before you go. One of our participants asked for, is it possible to get access to the Treasure Hacks demo folder on GitHub?
Yeah, I'll make it public and post it.
Okay, sounds good. Just send it to me and then I can post it on our Discord.
Oh yeah, sure.
Thank you. Appreciate it.